I would like to present the step 3 for the LAB1, which is a simple assembly program using a Wine32 library, and this program will display hello assembly on the console. First of all, the include a Wine32.inc will give us access to useful procedures such as write strings for displaying text and CRLF for printing a new line. Next, we move on to the dot data sections. Here, we define a message called a message, which contains the text hello assembly, and it is followed by a 0, which is act as a null terminator to mark the end of the strings. Then, the dot code section begins. There is where the actual instructions of the programs are written. Then, the main proc lines defines the start of the main procedure, which is actually similar to the main function in C or C++. Inside the main procedure, we first load the address of our message into the EDX register using move EDX of string message. The write strings procedure expects the address of the strings to be in EDX. Then, we call the write strings procedure, which brings the strings that EDX points to. In this case, which is hello assembly onto the console. After printing the message, we call a CRLF to insert a new line, which makes our output clearer. Finally, we call mProcess with a parameter of 0, which tells Windows that the program has ended successfully. The main ENDP marks the ends of the main procedure, and END marks the ends of the entire source file and tells the assembler that execution should begin at the main level. And let's move on to the demo sections. First, I would like to build this program, and I go to the build section and select this build solutions. Here, it will show that build 1 succeeded. And I will try to run these programs without a debugger. I press Ctrl and F5. It will show that the output hello assembly on the console, and I try to another method which I straight away press this debugger local window. It will show the same result, which is hello assembly on the console. That's all for my part. Thank you.
Good morning, Doctor. Good morning, Doctor. My name is Tan Shunda from SCSR 1033, Section 3. So in this video, I'm going to explain about the step 4, which the topic about the simple input and output, and also a demo build and run step. So let's start with the first line. Here is include arrayn32.inc. So this line includes the arrayn32 library. It gives the procedure like write string, read string, and the exit process. Now let's turn to the next line, which is the buffer size equal to 80. So this line defines a constant for the size of the input buffer, tells the program about how much space is reserved for the user input. And now let's turn to the next part, the dot data. So this is the code block that code block for the initialized or uninitialized data. The prompt byte asks the user to enter their name. The string is followed by 0, which is the null terminator. Is required by string handling procedure. The next line greeting byte will print a hello string later. And the next line, user byte buffer size duplicate 0, DOP 0. It declares a byte array named username, which preserves 80 bytes of memory. DOP 0 initialize all buffers size bytes to 0. So next turn to the next part, the dot code, and the main prop is meaning that is the beginning of the main procedure. The move edx offset from call write string. It moves the memory address of prompt into edx and will print the prompt text to the console. So the next part, move edx offset username, move ecx buffer size -1 call read string. It will set the edx to point to username where the input will be stored and sets the ecx to the maximum number of characters allowed, which is 79. And the call read string will read the line from a console into the username buffer. So the next part, move edx offset greeting call write string. It moves the address of greeting into edx register and prints hello to the console. The next part, move edx offset username call write string. It moves the address of the user's input into edx and prints the name that the user typed after the greeting. The call crlf will move the cursor to the next line after printing. And now here is the end part of the procedure. So now let's turn to the demo part. So I will build the solution first. And I will rebuild the solution. And it shows one succeeded.
This meeting is being recorded.
So now I will I will run the program now. So here the program is successfully run and display the please enter your name, which the prompt part. And now I will enter my name into the CMG, and here it has successfully printed the greeting part and my name and the username at the last part. So I think that's all for my part. Thank you, Doctor.
Hi sir, so I am about to run this code. It's from the LAB1 step 6. It's about the basic debugging practices. So for the first, I have to build the solution first. And then we can see the solution is built succeed. And then we can try to run it line by line by pressing the F10. So after I press, you can see. So here is the memory 1 window and also the register window, which you can find right here in the debug windows and memory 1 and so the register as well. So the first line I'm gonna run is to declare the variable. So we have 4 variables here, which is the result, variable A, B, and also C. And all variable is defined as a type of double words, which means that is a 4-byte variable, and this is the number value of 0 will be assigned inside the result variable, and this value will be assigned to a variable A, and the hash coming after the number value is mean that this value is a hexadecimal number, and all the value inside here will be defined as a hexadecimal number by default as well. So we can try to run it first by pressing F10 to will compile this line. So after we run, we can try to see is that correct to assign inside the result by checking their memory address. So first we can check the result first. So here is the result for here is the address for the result variable. So you can see 0 as well, so it means correct. And for the variable A, and this is the address for variable A, and the value is 00 ABCDE0, mean yeah, this is correct. And also is doing well for the DNC as well, so we can try to move on. And for the next slide, is the method is called the move method. This means that we have to move the variable A value, which is this value, inside the EBS register. So initially the EBS register have the value of this is, and then after we run this code, we have to try to move the variable A value, which is this value, inside the EBS register, so that after I run it, the latest EBS register value will become this value. So we can try to see. Yeah, 00ABCDE0. So means that this code is run successfully. And then for the next slide, which is this slide, add ECX variable B, means that we have to add the variable B to the ECX register. And for initially, the ECX register is this value. So this means that this value will be added up to the variable B, which is this value, and the result will be saved in the ECS register as well. So you can see, yeah, so here's the result in hexadecimal. And so with the next slide is the subtraction. So it's similar to the addition, but is deduct the value. So it means that the EBX register value, which is this value, will deduct this value, and result will be saved in EBS register as well. So this is the latest value for EBS register after they deduct the variable C. So for this is just similar to this, but set in the EDS by adding the EBS value with the EDX value. So it means that this value 00ABBED1 will be added up with 00BB10AA, which is the value for the EDX register, and then after they add up, the product will be set in the EDX register as well. So here you can see, after they add up, then the product will step inside this register. And for this line, it's just similar to this line, but another register. So it means that we have to add the ECX with the EDX, means that EDX, and it says this value will be add up with this value, and then the product will step inside the EDX as well. So here you can see, yeah, so here is the latest value for EDX register. And for this means that we have to move the EDX value inside the result variable, which we have defined as D0 for initially. But after I run this code, it means that we have to move this value 0223035 inside the result variable. So after I run this, the result variable will show the latest value of this instead of 0. So you can try run it, and you can check is that correct by checking the address or result. So address or result, and the value 02230365. So it's exactly same with the EDX register, means that we have run this code successfully. So for this line is called the dump rec to check to display the register, means it's just same with this right here. So you can try to run and open the dump rec here, so you can check. So we can try to see, and all is well, and same with the register here. So, and this is the code about, and we have to run it for the next slide. It means that we exit the debugging. So, and that's all from me. Thank you.
Hi guys, my name is Jin Chen. So today I'm going to show that how assembly code works. So what is the code we are going to show today? Is this one, basic arithmetic example. So this is a whole bunch of code we are going to explain today. So what is this code roughly doing? So what is this code trying to do is, okay, basically is we have the EAX here, and then we move this value inside this EAX, and then we do a series of action to this EAX, and then we trace the action inside the EAX. So this is what we're going to do today. So I move to right here. I'm going to show the code. So yeah, we move to the code. So right now I have already complete the code right here. So what we're going to do is, I have just said, we're going to trace every single action on each line. So as you can see, there's a red dot here. So I can cancel the red dot, and then I add them back. So the action of this red box is I'm going to trace each line of this code, only the line that I have put the red dot. So which means that I tell the debugging tool, this is the debugging tool I'm going to use to trace the action of this line, and this line. So other line that do not have red dot is is not going to trigger the action. So right now we're going to open a debugger, but the first thing we need to build a solution. Oh, sorry, cancel, and then we build the solution. So right now we're going to start debugging. Okay. So we are going to open every tools of the debug tool. The first thing is watch 1. We put at here. Oh, sorry. Okay, we arrange the window. So the second tool we're going to use is memory 1. We put it here. It's okay. And then disassembly we put it here. And then the third thing is register. Okay, so let's arrange the. So right now, a little bit messy, but basically we're going to do is trace the code. So what every single window do is, so register is to see the whole situation of this whole code. And then the watch 1 is watch a specific object to see the changes of this object. Let's say EAX. So EAX is the main focus of this watch 1. Of course, we can put another variable like a result VAR. So the next thing is assembly. So this thing is actually tell you that where you at right now. And then the memory is when you store something inside a variable. So when related to memory, we can use this to check the variable. So right now, as you can see here, we have the result variable. So because we move the EAX into this one. So of course, so let's try EAX equal 0. Okay, that's okay. Okay, so let us start debugging. So when we're going to start debugging, we either here continue, we push this continue, and then you move to the next bar, or either we use the F10. So right now, as you can see, this arrow is pointing at here, so we are right on this code, but we haven't activated the code yet, even though we add this line. So yeah, so right now we just want to move the 2000H into this EAX. So as you can see here, EAX is assigned to a random value here because we haven't assigned anything yet. So as you can see, the EIP is at here, and then okay, X here, we're going to add EAX. So EAX to see the changes on EAX. So right here, the assembly show that we add this code. Okay, so yeah, this memory is showing that what is going on to each variable. So right now, EAX. So right now, EAX is assigned to a very random code. So okay, right now we're going to press F10 to execute this code. So when we execute it, so F10, so we press EAX. As you can see, 2000 is successfully assigned to EAX. So as you can see here, register, the 2000 is successfully assigned to this EAX. So do in this EAX. So why is 8192? Because this is in decimal places and this is in a hexa. So hexa is base 16 and then decimal is base 10. So when you convert 2000 into a decimal, it will become 1892. So do here, assembly telling that we're going to move in this line. Now we keep going, press F10. So this code is at 1800. So what I go to expect is this this thing here will become 3A00, and then here will become, so we add 6656. So it will become 1484. So I think here also we'll do some changes. So we move to F10. So yeah, 3A001484, and then we check again for the EAX. So yeah, everything is going good. So right now we're going to add 1. So yeah, everything is going good. We add 1 here, and then we add 1 here, and then check again. So yeah, add 1, everything is going good. So right now this line is going to move EAX into this result of VAR. So we're going to put VAR. Okay, let me. So yeah, so we watch this VAR. Is there any changes? So 1, 2, 3. Oh, sorry, we haven't. Oh, sorry, I'm sorry about that. So this is the subtraction. So we subtract 501 to this EAX. So I think the EAX have changed the value. Yeah, 53500. I a little bit forgot what is the value beside before this one, but we have subtract the 501H. So yeah, I think the value for this is 14848. So which means that we have just subtract the 501. I forgot to look at this code. So right now we are going to enter this one. So we are going to move the EAX inside the result of VAR. So when we press F10, okay, right now we are successfully moved the EAX inside to this one. So we check. So yes, we have insert the value inside this. So as you can see, yeah, we have already insert. So as you can see here, no, I don't think so you can see here, okay? So right now, it's called the dump rate. So basically, this line of code is to show the whole value, just like here. F10. And then the last code is exit the code. So when I press F10, we are going to shut down all this thing. Yeah. So this is how all the code, and then this is how all the debugging works. I wish that I make my explanation clear. So thank you.